Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to do the first part of probably a three-part series on building some ToeJacks using some small 4-ton Harbor Freight bottle jacks. Now, I've had these bottle jacks probably for 2 years. Bought them with the intention, they're these small, they're rated at 4 tons. But I bought them with the intention of making some ToeJacks and just never got around to it. And I've had several occasions where a ToeJack would have come in good. I really needed a ToeJack, but I worked around it with pry bars and this, that, and the other. The latest was the toolbox rearrangement that you saw in the last video, where I put the intermediate box between the top box and the bottom box. In that last video, if you recall, what we did was roll this box. At the time was the top chest and the bottom chest. Rolled it over underneath my electric hoist over here. Picked this top box up and installed the intermediate box. Told you on that video too that I would tell you what this box weighed. The box and the contents at the time weighed 117 pounds. Much more than I could lift by myself, and would have been somewhat of an awkward to pick up by hand even with 2 people. But we got that installed in the last video and got it back in place. And as you recall, it was set pretty high. It had the casters underneath it. And in that video I said that I would probably take the casters out. And I almost immediately decided that they had to go. The box was just not steady at all sitting on those casters. It was wiggling. I didn't think it would turn over, but it was just aggravating. You come up to the box and try to pull a drawer out and the whole cabinet shake. Plus it was simply too high. It was another 5 inches with the 4-inch caster wheels and then the frame itself. To get those casters out from under it, I had to use pry bars, and well, in fact what I wound up doing was rolling this back over there, setting the top bench, hoisting it up, setting this top box down on the floor, taking this off, emptying out what I put in it, set this off, took the 2 bottom drawers out of this, emptied the 2 top drawers, turned this over, took the casters out from under it, reassembled it, and then had to kind of wedge it all back in place. Where a ToeJack would have been ideal to have had 2 of them to pick this up in place, not having to unload anything, put some blocks under it, take the casters out, and then gradually let it back down. I didn't have the ToeJacks ready, but I hope before another job like this comes up, I'll have them ready. Let's look back on the workbench and I'll show you what we're going to do in today's video. As I said, this is probably going to be 3 different videos involved in that. The first one today is going to be preparing the jacks, getting them ready, which what that's going to involve is making some handles for these. Of course, you know, you can use these loosen and tighten the valve in it. But I anticipate situations where this might have to be used in close quarters. So what I'm going to do is make a handle for each one of these. Now, I've made handles before for hydraulic jacks. Here's a picture of the 20-ton hydraulic jack that was on my press. Came originally on the press, and the handle I made for it. And here's a picture of the air over hydraulic jack that I added to the press and the handle on it. What we're going to do is take this piece of 1.5 inch stock, aluminum stock here, and make 2 handles out of it. I'm going to turn each end up 550 thousandths. Going to turn it down to 0.75, both ends. Then we're going to carry it over to the mill, and instead of using a bolt hole pattern to put our grips on the handle, kind of like what's in this picture, instead of using the bolt hole pattern, I think what I'm going to do this time is use a spin indexer and probably put at least 5 or 6 scallops around in that. The other thing we're going to do in today's video too, these jacks will be mounted down individually to plates, steel plates, that the toe will be off on this side, and these will be mounted down. So what I want to do is drill these 2 locations, probably back here in the back, this location, and maybe over here as well. Drill them so that the plate that they're going to be mounted to will be drilled and tapped, and these will go directly in. The other thing I want to do is do a little bit of grinding on this jack right here. I'm not sure what you call this part, but I want it so the end of this piece is flush, no matter the position, would be flush with something parallel from here, so it doesn't get in the way of the tube that'll be over here, or even the item being jacked. So let's turn to the mill, or to the lathe first, and get started on this piece. All right, again, we want to take these, turn it down 550 thousandths. So zero out the z-axis right there, come in 550 thousandths, and I'll set my carriage stop. And let's see, I believe I said this was 1.5 inch material. Yes, and we want to come down to 0.75. So we want to take 75 thousandths off. Okay, folks, I apologize for all that stopping and measuring and remeasuring instead of just cutting, instead of just turning that 1.5 inches down to 75 thousandths. In other words, turning 750 thousandths off of it. But got some kind of discouraging news this morning. That's on my mind. I probably really shouldn't even be doing this right now, but anyhow, we got that. I'm going to turn this around, do the same thing to the other side. Turn it down to 0.75. Okay, I got it turned down on both ends now. Got my head together a little better. Definitely need to have my head together before we turn over to the mill with the spin indexer, but I'll get that set up and bring you right back. Okay, several viewers showed interest in the last video of wondering exactly how I use this, moving items off the various lathe or the mill. I'm going to take the mill vise off this morning to mount the spin indexer. For the mill vise, I have this simple little adapter made. That will actually go under the vise jaws. And that pretty much puts it center of gravity, over the center of gravity on it. And of course it can sit right there in its home until I get ready to put it back on. I'm going to get the spin indexer mounted on here. I'm going to clean up a few chips first, get that mounted on, then bring you right back. Okay, I've got the spin indexer mounted over here on the mill now. If you're not familiar with what a spin indexer is, on the back side of this wheel are graduations from 0 to 360 degrees. When we get ready to actually start cutting, I have another camera set up over here that I'll show you how this is advanced. But this little notch right here corresponds with the 0 on the graduations, and there's a 0 on the housing as well. So those two are lined up now. This style spin indexer uses a 5C collet. I have a 5C collet here that's the 3/4, and I also have my work stop installed in the back here and locked down. That way the workpiece can't push in. So we'll insert that. Once that catches, we want to tighten it good. All right, now next thing we need to do is find the center. Get my edge finder here. We want the center on the y-axis. The x doesn't matter, as we're going to be cutting back and forth on it. Alright, we'll zero out the y right there. And since I'm on a round surface here, and I'm not 100% sure I'm at the widest point, I'm not going to change my depth setting. That way I know I'm touching off on the same spot on both sides. All right, now we just go Y 1/2 on the DRO. We'll come back to 0 and lock the Y down. We will not need to unlock the Y anymore. All right, to make these cuts, I'm going to use a ball end mill. This is a 3/8 inch ball end mill. Now, what I want to do now is just touch off, and I'll zero right there. I'm not exactly sure how deep I want to go now. I want to go at least the width of the ball. So everything's set on 0 here. All right, I'm going to come down. I think I'll start with 50 thousandths. I think what we're going to wind up is 187 thousandths, which is half of the 3/8. Here's 150. All right, there's 187. All right, now we're ready to advance. We want to put 6 of these in here. So 360 degrees divided by 6 is 60 degrees between each turn. All right, over here in the little camera, see this on the first one was 0, 0. I'm going to advance it to 60 degrees now. So the 60 on this dial is 0 here. All right, we'll go back. 50 thousandths at the time seemed to work good, so we'll go with that. Okay, we're down to the 100 thousandths now. That's 150. Now the 187. All right, over here on the back, now we'll go from 60. Little pin is tight. We'll go from 60 to the 120. All right, after the 120, we'll go, of course, to 180. Now we go to 240. And finally to 300. All right, I think that's got our 6 sides cut, or 6 scallops cut. Pull this out here. All right, I'm going to put this over in the lathe and part it right in the center. All right, I got a little mark here at the center way, and I'm just going to use my micrometer to get set up on that. These are going to be two different knobs, of course, so they don't have to be 100% exactly the same. That looks center to me. And this is aluminum, of course, but I still like to keep a little cutting oil on it to get those chips out of the way. Okay, I may have to look back at the video, see where that piece fell to. But for right now, let's face this off, get that a good clean surface, and then I'll find that other piece off camera. Okay, I see it. All right, I'm going to clean up the other end of this other one. Then I'll carry them both over to the Scotch-Brite wheel, clean them up, come back, and then we'll bore for our hole that will go over the valve that's on the jacks now. Okay, I got both knobs cleaned up good, all sharp edges buffed off. Did it on the Scotch-Brite wheel. Now I've got one of them in here with the scallop handle part up against the spider. I've got a 7/16 end mill in, and I'm going to try to cut that to 550 thousandths deep that we turn this down. That'll be a tight fit over the valve. Let's see how this end mill in the lathe chuck works. Alright, that cut us a very nice hole in there. That, like I say, will be a tap-on tight fit on the valve. I'm going to do the same thing to the other one. Then we're going to go back over to the mill and put a grub screw, 2 grub screws in each one at 90 degrees. I'm over at the mill now, and I've got the one of the knobs mounted in. I found center on X and Y. We're going to use some 1024 grub screws. So I'm going to drill this. Now we'll put our 1024 tap in. We'll slow our speed down and put just a little WD-40 on there. Alright, I'm going to turn this one 90 degrees and do the same thing. I've got the V-block in the vise lined up with the edges of the vise, so everything should be able to stay locked down and not have to recenter again. And again, I'm just using my micrometer on getting this at 90 degrees. Okay, other than a little bit of deburring, I think we're done with one of the knobs. I'll do the other one off camera, and then the only thing that's left to do with the knobs is install them. Okay, I've got the handles installed on the jacks now, and what I've done is take the handle receiver off on one of them. And what I think we need to do, if you notice there's a line here, I think all I need to do is carry this on out to the edge, and that will give all the clearance that's necessary. I'm going to do that off camera. All I'm going to do is go in there to the 2x72 belt grinder, lay this down flat, and just carry this line on out to the edge for both of these pieces. Okay, I've got both of these pieces ground down now. As you can see, what I did was just simply carry that line on out to the edge, and that should give plenty of clearance for the pumping action once we get it mounted on the base. Now what I want to do next, and last thing as far as the jack prep, is to drill some holes in this base to mount this down to the plate. Now that's probably standing 8 inches tall, and yes, I've got drill bit long enough to do it. These are 12-inch bits. This was a 5-piece set. I have to tell on my grandson a little bit. Several years ago, he was him and his mom were staying with us for a while, and his pellet gun, one of the pellets hung in it. I guess it was low on the CO2, but instead of stopping right then, as a typical 12, 13-year-old might do, he kept shooting, hoping to push the stuck pellet out, and obviously that didn't work. But I bought this set of long drill bits and found one small enough to go up in the what's a BB, .177, but went up in there, cleaned them out. I think there was like 6 or 8 of them in there, but that was the only bit that I've used in this set. This is a 5/16. I'll be using 1/4-inch bolts to hold this down, but I want just a little bit of slack in it, so I'm going to use the 5/16, and that don't look like it's really straight, does it? Let's see if we can get it started. There we go. This being cast iron, I'm not really concerned about it grabbing. Alright, there's those 4 holes drilled through it. I'm going to do the same thing to the other one off camera, and then we'll meet back on the workbench and do a quick recap on this video. Okay, I think that's going to do it for this video. What we've done is made our knobs to replace the handle with. We've ground this off to give a little more clearance in the back, and we've drilled our 4 holes to mount these jacks onto a plate. In the next video, we'll look at the mounting plate that we're going to use for each of the toe jacks, and also the uprights that we'll use to make the toe out of. It's going to be kind of involved making all this, but I wanted to go through each step, document each step. So it's probably, like I said earlier, it's probably going to take 3 videos. But I hope you've enjoyed this one. Take care, and I'll see you on the next one.